All right, today is Thursday. We're gonna pick up with part two of this study guide. So yesterday we started on part one, but we're gonna jump over to part two and then we'll come back to part one. So if your connection is loading, see if it'll open up part two. It's in the same assignment as the afternoon, DeKyla and Braylon. And then I reminded us that this chance everyone can participate in reading the question, telling us how to solve the question. Giving us strategies and keywords. Fine, everyone can participate some way, shape, or form. I also reminded us that our work for these 9 weeks is due by next Friday, March 12th. Some of you have reached out concerning what you're missing. If I have not told you, I will let you know after the buses leave today. For those who ask. Internet up? All right. So those of you at home, if you can open up your study guide, part 2, that's what we're about to look at. All right, part 2 reads, Valerie is an architect. She is working on the plan for a house. Valerie is drawing the front of the house on a coordinate plane. She has just finished drawing window QRST, one of the regular front windows. They asked us to complete the table to indicate which transformations could be used to create another rectangular window, the exact same size and shape on the opposite side of the front door, equal distance from the middle door. Transformations. What is a transformation, or what does it mean? What does transform mean? All right, so a transformation is a change. 4 kinds of transformation. Anybody know any kinds of transformation? All right, one is a rotation. What happens during a rotation? Move around how? What does rotate mean? What that mean? What you... Oh, turn around and point. What's a reflection? Oh, so a rotation is where we turn around and point. Reflection is a mirror image. And then we have a translation. What's a translation? Cha-cha now.
I feel like
what Cha-cha asked us to do?
Oh.
Cha-cha now, y'all. What the first thing they tell us? Oh, so a translation means to slide. I remember that by thinking of cha-cha. And the 4th one is known as a dilation. That's when the figure gets bigger or smaller. 4 kinds of transformations. Transformation is a change, either a rotation happen, a reflection happen, a translation, or a dilation. All right, so they want us to figure out what happens, and they said this shape is going to be the exact same size and shape on the opposite side of the door. So they pretty much want to get a whole nother window to match up with this window. I'm going to draw where it should be. Uh-huh. Yeah, I had to call the people. They had to email it back to me, and then I had to put it in the form. I still have them saved. Mm-hmm. Okay. 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 Give me 1 second. Let's see. Let's see. See if I have this one, and this one. First one. Uh, Okay. So we already said we want to put the same window on the other side. So it's up to us to figure out if these answer choices at the bottom could have happened. Now the first thing they mentioned is a reflection. So think about reflection. That means a mirror image. And I always saw the reflection of if I was to fold it on that axis, would it give me a similar image? All right, so the first one they mentioned was a reflection over the x-axis. We all know what the x-axis is down here. So could I reflect that window and I'm gonna fold it on this axis and now it's gonna be down here? Would that work? Next thing they said was a possible reflection over the y-axis. This is the y-axis. Can I fold on this line and I'm gonna get a mirror image? Mm-hmm. We over here trying to get here. Can I fold on this axis and I'm gonna be there? This is a house. House got a window on that side. We're trying to put a window on that side. Can I fold on this y-axis and that window over here that'll line up over here? You look in the mirror, what happens? Do you see yourself farther back or is it the exact same place? So if I was to fold right here, am I gonna get the same number? Yeah. Yes. So then the next one talks about a rotation. Rotations work several different ways. But first we gotta know directions. Which directions is clockwise? Look at a clock. Clockwise is going which direction? Okay, to the right. So that means counterclockwise is which direction? To the left. For those of you joining us, Stephen, this is part 2 on that review if you were wondering. We may not have time to review next week, so I'm jumping to give us at least parts on part 1 as well as part 2. So then rotations also gives us the degrees. 90 degrees would be one turn, or I move one quadrant. $90 and $90 is how much? So rotation is always moving increments of 90. So then 180 degrees will be how many turns? That's 2 turns, or I move 2 quadrants. What's next? 90, 80. Then we got 270. That'll be how many turns? 270 plus 90?
360.
So then 360
4
degrees,
turns.
4 turns. So they mentioned degrees. The first one said rotate 90 degrees clockwise. Now we already said clockwise is which direction? To the right. 90 degrees will mean how many turns? 1. Rotation is also the one that I have a little sticky to make sure I see how it's moving. So if I'm over here and I move 1 to the right, would that be the same window? All right, I look like this. I turned 1 time. Nope. All right, so then the next one said rotate 180 degrees counterclockwise. Which direction? Left, how many?
2.
2.
All right, so here we're gonna move 2 times. 1, 2. Is that our shape? Let's do it again. So we got 1 turn, and then we got 2 turns. Is it up there in that quadrant? It's in the wrong quadrant, but it would have worked. All right, the next one says translate. We already said translate means to slide. So looking at this image, give us one of those alphabets. Which one we want to look at? Q, R, S, or T? S, all right. So this is S. So we're going to translate or slide S 7 units to the right. 1, 2, 3, 4, 5, 6, 7. Would S be right there? Oh, yeah, that'll work. D then said translate 10 units to the right. If I go over 10, would I still be in the right position? Nope. Any question about it? I hate part 2 for 8th grade because it had transformation. And we just, since I've been here, we have never done well with transformation. All right, number 2 says if window QRST is translated 3 units to the left, QR is blank to the other QR, and then QT is blank to RX. So let's follow what they told us. They said translate 3 units left. Translate meaning to do what? Slide. So we're gonna slide over 3 units. I'm gonna look at T. 1, 2, 3. So T is now here. 1, 2, 3. S is now here. Q is now here, and R is now here. I'll put the apostrophe behind it, so that's what the apostrophe means. All right, so now that I have those 2 different shapes, this is QR, and then this is QR prime. Would you say they are congruent to each other? One is greater than or is smaller than the other? Congruent would be correct. There's also a notion. We get congruent shapes. What does congruent mean? So we get congruent shapes anytime it translates, anytime it rotates, or anytime it reflects. We get a congruent shape. We get a similar shape, and a similar shape have the same size, same shape, but a different size. We get that anytime it's a dilation. So with the first 3, we would end up getting a congruent shape. With the other one, we would end up getting a similar shape. we already said it'd be congruent. Then they asked us about QT and RS. QT prime, so that's this one. Ask us about that to RS. Parallel or perpendicular? It then states Valerie instead decides to rotate QRST 270 degrees counterclockwise about the point 0, 0 to create window LMNP. After the rotation, vertex M would now have what coordinates? All right, so they gave us QRST, and the new triangle, well, the new rectangle will be LMNP. So M is going to correspond to what side? Right above it. R. So QRST in that one is going to be the same as LMNP. So once again, I'm going to follow what they told me. Counterclockwise is what direction?
Left.
Here, we're going to go left 270. Tell me how many times? 1, 2, 3. So now we have turned the long way. And that is now our window. And I told you I'm doing this sticky just to keep up with where they will be at. All right, and we said M will correspond to what letter? And where is R, the new R, located at? The new one. 5, what does it look like? About 5, 1? Rotation is the only one that confuses me. So I always have me a little sticky to do my little rotations. Any questions about 1, 2, and 3? Part 2 don't have many questions on it, only be about 6. Trying to figure it all out. All right, we're still talking about Valerie. Now they said her partner, George, decides to include a circular window W to the left of the rectangular window. So we see the new window he is at. A says if George wants to create another round window, W pi, on the opposite side of the front door is window W, an equal distance from the front door. So they wanted the same place. Where is W in on the left side? Mm-hmm. All right, look at the dot for W. Just look at the X coordinate. -7. So when I come on this side, I'm going to see it be at what? I'm going to be at 7, positive. It'll be the opposite. Hello? All right. Look, that's what I was telling the student, and I had to forgot all about it. Okay, and I don't think I kept a copy of them quotes. I probably should have, but I'm gonna try. I'm gonna try to go back in my email and see if I can find them. Yeah, I still got the requisitions. I just don't have the additional stuff. Okay. I got you. All right, so this will be our new window W with the apostrophe. All right, so they said George, he did that. So we already did it. And now they said he want to translate from this W over here to this W. What does translate in? Good job, slide. So y'all said this was at -7 and that's at +7. How many total units would he have to slide? Think of absolute value. -7 to 0 is how much? And then 0 to +7. And then 7 and 7. Good job. All right. They also said he could have reflected that window. So instead of sliding it over, he could have just reflected it. Would he reflect on the x-axis or the y-axis? Which one can I fold over? Good job, y-axis. The one that's going up and down. All right, down at the bottom, they asking us about true statements. The first one mentioned congruent shapes or not congruent. Will them ones be congruent or not congruent? They're going to be congruent. So we're going to get rid of C and D. And then A says, because there's a sequence of rotations, reflections, and translations. And B said there's no sequence of rotation, reflection, and translation. All right. So A will be our answer. That is correct. It would be because it did translate. It would be because it did translate. Any questions about it? Everybody got what you need? Okay. All right, and now reads, Valerie plans a series of triangles to decorate the bottom edge of her house. She draws the first and second triangles as shown in the figure, which is a portion of the coordinate plane. Number 5 says, if the first and second triangles are congruent, complete the table by indicating whether each statement is true. Now, what do we know about congruent shapes? Equal, same size. So that means if I'm 6 units in the first triangle, what am I going to be in the second? Good job. So the first question asked us, it said corresponding sides should have the same length. Would they? Yeah, y'all just told me they equal. The second one said the orientation of the second triangle is the same as the orientation of the first. Orientation is the direction of it. So looking at those triangles that they have gave us, we got the first one, we got the second one. Would you say they go in the same direction? The right one was turned over. All right, the last one said the corresponding interior angles are congruent. Good job, that is correct. Sides and angles are also going to be the same. All right, the second one said, if second triangle is translated 3 units to the right to create a third triangle. So I'm going to do that. 1, 2, 3. So this will be triangle 3. Looking at these statements, they're talking about the perimeter. Will perimeter 3 be equal to perimeter 2? Would it be greater than perimeter 2? Or would it be less than perimeter 2?
Equal.
They are congruent. Good job. Good job. Any questions about it? All right, that was the last question in part 2. So now we're going back to part 1. What we stopped on yesterday? 10. You got it to me? All right, so we're finna go back to part 1, picking up at number 10 from yesterday. Did we finish it? Okay. Okay. This deal with integer exponents. when we multiply by the same base, we would add exponents. We did 10. Answer was 8. Okay, so London, get with Tamia to get 10, just so we can try to squeeze in as much as we can get. All right, number 11 says, consider the system of equations. What is the solution of the system of equations? What you recognize on that graph? Line going through? What you call going through? What's the correct vocabulary?
Intersection.
So anytime they mention a solution to a system of equations, if they give it to us on a coordinate grid, we just want to look at where they intersect. And looking at this graph, what would be the point of intersection? Good job, Rebecca. 6, -4. So anytime solution and they gave us that graph, we just need to know where does it intersect. We got it? All right, number 12, it says consider the right rectangular prism. You all may or may not remember when I taught this, but this is something that we'll have to use what's known as the Pythagorean theorem. Pythagorean theorem. Pythagorean theorem states that a squared plus b squared equals to c squared. And they want us to find the length of this diagonal. So we know, okay, let me draw a triangle so y'all can see the relation to it. A and B are your legs. C is always the diagonal or your hypotenuse. It's always your longest side. All right, so they want us to get a diagonal, but before we can get this diagonal, we got to find something else. We need this diagonal on the inside of this box, or this bottom triangle. At the bottom. So if I'm looking at the bottom, trying to ignore all the other stuff, what would be my A and my B? Good job. So I'm going to substitute that in. So that would be 4 squared plus 2 squared equals to C. What is 4 squared? 2 squared?
16. 4.
All right, 16 plus 4?
20.
Good job. 20, how do we get rid of a square? All right, that's when we take the square root. So the value of that would be the square root of 20. I'm going to leave it at the square root of 20 because it did not give us a whole number. And I'm going to let it. All right. So now that we have found that piece, this is the main triangle that we are looking at. So now what would be the A and what would be the B? We're now looking at this blue part. Don't look at over there, only the blue. Which one going across? What value? What we just say that was? So that's going to be our A, and what's going to be the B? Good job, the 2 up here. So now we have square root of 20 squared plus 2 squared is equal to that C that we need.
Good afternoon. We are getting ready for dismissal at this time. Thanks, students, for coming on.
What happens to a square and a square root?
And who will need to be present on tomorrow for remediation. Ms. Walker, you're needed at the back gate. Ms. Hope Walker, you're needed at the back gate. All
Square and
staff
square
that
root
is
get
not
rid of each
class at
other,
this
so we're
time,
going to get rid of that, leaving us to just what?
go to your afternoon duty post. All staff that is not holding a class, please go to
So
your
that's why I was
afternoon
saying
duty
the
post.
square root and that square, get rid of each other, we know so that's 2. All right, so what's 2 squared?
4.
20 plus 4. Good job.
24.
And how do we get rid of that square?
Square root.
Good job. And will be the correct answer. Any questions about it? Yes, it's confusing, but that's one of those skills that's gonna stick with from now when you go over there to college algebra, high school algebra, whatever you move past beyond this point, you most likely gonna see the Pythagorean theorem. They're not always in a box. Usually they'll just give us a triangle and we just do a squared, b squared. All right, any questions about it? Everybody got what you need? All right. All right, 13 says, consider rectangle S and rectangle W. Which statement is true? Now, when I look at it, I recognize the first words that are different.
I need Kylie Lee to report to car rider today. Kylie Lee to report to car rider.
Not similar or similar. Let's look at this shape. What happened from S to get to W?
It got bigger.
All right, it got bigger. So if it got bigger, would that mean we are similar or not similar?
Not similar.
All right, now let's go back to them transformations. Y'all took them notes down a while ago? We got a congruent shape when we translate, rotate, or reflect. When do we get a similar shape? When we dilate. Dilation tells us the shape got what? So if it got bigger,
Bigger.
is it similar or not similar? It is similar.
Similar.
That's because it's a dilation, it got bigger. So then in thinking of that, yesterday we had a problem with dilations. We discussed scale factors. If I got bigger, should my scale factor be a half or should it be 2? Good job, it'll be 2. Good job. Any questions about it? Everybody got what you need? Okay. I don't be trying to rush, but I just be trying to get us to cover as much as we can. All right, number 14 said, consider the relation. It asks which point could be added so the relation is a function. How do we tell if a relation is a function? I think we had a problem yesterday. They gave it to us in a coordinate grid. That when we have every x value to one y value, or someone told us the x does not repeat. The other day we used the pencil line test. Is it coming back to you? On the coordinate plane, we held up our pencil and said if it touched more than once. So when they give us ordered pairs, notice we said the x does not repeat. So that's the only coordinate I'm looking at, those x's. So I'm looking at all the x's I have. None of them repeat. But the question asks, what could I add so that it could be a function? So looking at these answer choices, I'm going to still look at the x's. And which one will give me an x that I do not already have? X is 0, there goes 0. Can't use that one. -5, I don't see it up there. A will be the correct answer. Good job. So when they're talking about functions, we want to make sure that x is not repeating. We can care less about y as long as that x isn't repeating. Any questions? Got it? Okay. All right, 5 said consider the figure. They said trapezoid QRST is translated 4 units left and 7 units up. What does translate mean? Slide.
Slide.
What alphabet we want to look at? Q, R, T, or S? Q. All right. So we're going to take Q. We're going to go 4 left. 1, 2, 3, 4. And they also told us 7 up. 1, 2, 3, 4, 5, 6, 7. Q will be right there. When the second Q with the apostrophe. All right. R is 3 units from it.
Second through third grade bus riders, you are dismissed. Second through third grade bus riders, you are dismissed.
Did they call you for car ride? Go ahead, man. You a car ride today? I ain't saying, go on. I don't want y'all to miss your people. I'm gonna go ahead and finish this one. So we went from down here to up here. They want to know what would be the length
Ms.
of
Thompson, you're needed in the front
TS.
office or call the front office. Tanya Thompson. Ms. Tanya Thompson will save the children. You're needed in the
See
front
if you
office
can
or
see
call the
how
front
many
office.
units between T and S. All right, Lonnie. All right, look again to me. Look closely. Steven says 6. If you can't see it up there, look down here on this one. All right, let's have a good one. 1, 2,
Fourth and 6th
3.
grade car riders, you are dismissed at this time. 4th and 6th grade car riders are dismissed. K-3rd car riders, you are dismissed.
And the whole point was to remember that if a
K-3rd,
translation
4th, 6th
happened,
car riders, you are dismissed at this time.
we know we had got a congruent shape. So I really didn't have to draw it to look at it because whatever TS is in the first shape, it's still gonna be the same in the second shape. Yeah. Any questions? All right. I'm trying to make it through the next one so y'all can get caught up with the others. All right, it says point Q represents the smallest integer greater than square root of 22. What's an integer? All right, an integer are those positives and those negative numbers, including 0. So that means we're looking for a whole number, positive or negative, including 0. And they say it is greater than the square root of 22. Well, let's find the square root of 22. Check that. Square root. Don't square it. Do the square root symbol. The one right there beside the division sign. Gave you a decimal. What you got? Okay. Get the door from the table. All right. So if that's at 4.690, and they told us we want that smallest integer that's greater than it. Now if I write it down. But they didn't ask you for a slip, did you? Okay. We'll see when we get out there. All right, so if that's at 4.69, what's the next whole number to get to Q? All right, what whole number we got now? All right now we got 4. So if I go over a little bit more, what am I going to end up at? Yes. Remember they said the smallest integer that's right next to it greater than it.
578 car riders are dismissed. 578 car riders are dismissed. K1 bus riders are dismissed. All car riders are dismissed at this time. kindergarten, first grade bus riders are dismissed only at this time. Thank you.
All right, so we're gonna start right there at 16. So that means we need to pick up at 17. Tomorrow is Friday. I will most likely do another review session just to make sure that we are prepared for a test on Monday. We do start 9-week test on Monday, so there's a possibility we may not be having class to review, but if I do some sessions in the evening to make sure or to help you complete the rest of your study guide, I would definitely let you know. See y'all later.